Hi everyone, UCI Physics. Classical physics is like a giant instruction manual for the universe. Let's talk about it. It helps us understand how things move and why things fall. Think of it as the foundation of our understanding of the natural world. Long before we launched rockets into space or developed theories about the Big Bang, classical physicists were hard at work unraveling the mysteries of the world around us. One of the central ideas in this field is the concept of motion. How do objects move? What makes them speed up or slow down? Classical physics provides clear answers to these questions. Another important concept is force. Forces are what cause objects to move or change their motion. By studying forces, we can understand why things fall to the ground, why planets orbit stars, and countless other phenomena. Classical physics doesn't just explain the motion of objects here on Earth, it extends its reach to the cosmos. By applying the principles of classical physics, we can understand the movement of planets, stars, and even entire galaxies. It's a testament to the power of these fundamental laws that they hold true from the smallest particles to the largest structures in the universe. Sir Isaac Newton stands as a giant in the history of science, and his contributions to classical physics are unparalleled. Born in England in 1643, Newton was a physicist, mathematician, and astronomer who revolutionized our understanding of the universe. His work laid the groundwork for centuries of scientific advancements, and his laws of motion remain cornerstones of classical physics. Newton's laws of motion are deceptively simple, yet they explain a vast array of physical phenomena. The first law, often called the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. This law helps us understand why a book resting on a table won't suddenly fly off on its own. The second law tells us that the force acting on an object is equal to its mass times its acceleration. This law explains why it's easier to push a small car than a large truck. The third law states that for every action, there's an equal and opposite reaction. This is why when you jump on a trampoline, the trampoline pushes back on you with an equal force, propelling you into the air. While Newton's laws were groundbreaking, the story of classical physics doesn't end there. Many other brilliant minds have contributed to our understanding of the universe. One such figure is Galileo Galilei, an Italian astronomer and physicist who lived in the 16th and 17th centuries. Galileo is perhaps best known for his astronomical observations, which challenged the long-held belief that the Earth was the center of the universe. Galileo's experiments with falling objects also made significant contributions to classical physics. He demonstrated that objects of different masses fall at the same rate, a concept that challenged Aristotle's earlier ideas. This insight helped to refine our understanding of gravity and its effects on objects in motion. Galileo's work, along with that of Johannes Kepler, a German astronomer who formulated laws of planetary motion, further solidified the foundation of classical physics. These pioneers of science, along with many others, helped to build a comprehensive understanding of the physical world. Their work paved the way for the technological advancements we enjoy today, from airplanes and automobiles to computers and smartphones. The principles of classical physics are essential for designing and understanding the workings of these technologies. As our scientific knowledge progressed, however, it became clear that classical physics couldn't explain everything. This led to the development of modern physics in the early 20th century, a field that deals with more complex phenomena such as quantum mechanics and relativity. These new theories revolutionized our understanding of the universe at the subatomic level and in extreme gravitational fields. Despite the rise of modern physics, classical physics remains an incredibly important field. It forms the foundation upon which our understanding of the universe is built. The laws of motion, gravity, and other classical concepts are still used today in countless applications, from engineering and architecture to medicine and meteorology. Even in the age of smartphones and supercomputers, we rely on the principles of classical physics to understand and interact with the world around us. The story of classical physics is a testament to the power of human curiosity and our relentless pursuit of knowledge. From the everyday motion of objects to the movement of celestial bodies, classical physics provides a framework for understanding the universe. While our scientific understanding continues to evolve, the core principles of classical physics remain as relevant as ever, shaping our understanding of the world and driving technological innovation. Next we talk about general relativity. Catch you in the next one. Stay with UCI Core.